Hey, so today we're going to talk about borders and vertical gaps. Let's start with the borders. First of all, I need a model for my border. So I'm going to move all of this out of the way and I'm going to hit Shift-C. And we've done it 3 times already, you know the drill. And of course, I encourage you to take a little bit more time with your models. Well, let's start by adding new point instance nodes. I'm going to select this border corner and this border straight collection. I'm going to use a point separate node because I already know I can use this corners mask to decide which border goes in the corner and which one is the straight wall. Now we need to snatch some points from other geometry. So I want to get the points that feed into the entire upper section of the buildings because that's where I want the borders to be. So I'm taking a look right now. This is the path that leads into the upper section. If I disconnect it here, you can see the upper section disappears. So I'm going to get myself another point separate node. I'm going to call this borders. And I'm going to put in the geometry too. So now we know whenever I play around with a borders attribute, we will be able to decide where to go from here. So I'm actually going to grab this attribute compare node that distributed the ground floor to the bottom level and just duplicate it. And instead of ground floor, you guessed it, borders. And now if I change this value, for example, to 4, well then on height 4, or I guess height 5 in this case, you get this cutout. So now if I plug in these nodes that right now lead into nothing, into the join geometry, and if you want to be clean, you can maybe create a new join geometry and, kind of connect them before we put them in here. You now should get your borders as they are supposed to be. So we have set up the logic for the borders, but rather than just being able to place a single border, I want to have multiple borders that are at even distance distributed throughout the building. And to explain you how to do that, you know what, I'm quickly hop over into Photoshop. I'm going to explain to you now how we are going to use the modulo operation. If you know what I'm going with, just skip this section, or if you don't care, do it as well, but I'll try to explain the logic behind it. Now let's imagine you have a number that continually goes up from 0 to infinity or whatever. For example, our position z, which is the height of our building. And distributed throughout, you would have like 1, 2, 3, 4. Those are the increments. And if I plug this constantly rising number into what is called a modulo operation, and what a modulo operation is, it essentially just returns the remainder of a division, which sounds complicated, but if you have a modulo of 4 and you divide 1 with 4, a modulo operation just looks at the 1 and says, you know what, I cannot fit a 4 in there, so it's essentially 0 with 1 left over. So modulo would give you a value of 1. If I would try to divide 4 by 4 using modulo, I would get a 0, because you can put a 4 one time into another 4, and the remainder of that operation would be 0. If I would get higher than 4, the 4 fits in one time here, leaving behind a remainder of 1, and modulo would return 1. So you can kind of see, no matter how high our input is, we will always get a number that is somewhere between 0 and 3. And if I now take another color and try to map like a modulo curve on here, modulo on the basis of 4 from 0 is 0. The same thing for 1 would return 1. The same thing for 2 would return 2. The same thing for 3 would return 3. But when we get to 4, well, modulo of 4 is actually 0. So now we are back at square 1. And now modulo of 5 would return 1. Modulo of 6 would return 2. And so on and so forth. And every time we hit a number that is evenly divisible by 4, we go back to 0. And that way we can convert this evenly always rising number that goes straight up into this kind of sawtooth pattern. And if I would input this modulo value now into a point separate node, which expects an input of either 0 or 1. When it's 0, it's going to return geometry 1, and when it's 1, it's going to return geometry 2. It will always return geometry 1 once we hit the 0 spot, and the rest of the time it will return geometry 2. So as you can see, using a modulo operation, will give me this number that frequently appears with this nice gap in between. And the size of the gap is just this number that we decide, which is the basis of modulo operations. Now, I'm sorry, mathematicians, I probably butchered this explanation. I hardly know math. The math I know is in German, so I guess the terminology was probably wrong all over the place. I don't know if this explanation made sense to any one of you. Anyhow, let me mute this borders attribute compare node because we actually don't need it, and instead get an attribute math node, which is this one here. And if you change this operation, you will maybe find that there actually is a function called modulo. Our input should be position z, as we discussed, which is the value which will return 1, 2, 3, 4, 5, 6, 7, and so on and so forth. The second value will be a float, and this one will essentially be the frequency of our borders. And if I now write in 4 into here, it will return 1, 2, 3, 0, 1, 2, 3, 0. And whenever it returns 0, well, first of all, we have to write the result in borders. And whenever it returns 0, it will output geometry 1. And you can see the problem, we kind of switched the inputs around. That's easy to fix. I'm just going to plug this into geometry 1 and this into geometry 2. And now we have nice and even frequent borders. And to prove that, I'm going to increase the height to something like 50 or something, scroll out. And if I now change this modulo value from 4 to 2, every other floor will have a border. And now if I switch this value to 6, now every sixth floor will have a border. And of course, we can now take this remaining seed value, plug it into B, and say maybe we want to have a minimum of 2 and a maximum of, I don't know, 15 floors perhaps, with the default being 5. And now this seed should determine the frequency of our borders. Now, the vertical gaps, we have to start by making a decision, which is how do we want our vertical gaps to appear? Do we want an entire column to be replaced with something different? Do we want to maintain the ground floor? Do we want our borders to cross these vertical gaps? Or do we want those vertical gaps to override the borders? I think I want my vertical gaps only in those places where I haven't already placed something else, which is in some kind of way special, like the borders. So that is where I will have to insert. Let me quickly look for the place here. Well, this is our little tree where we separate off all of our different building blocks, and I will have to insert my vertical gaps in between these two nodes, because at this point I've already declared the ground floor, I've already declared the borders, so I'm safe to insert my vertical gaps here. I'm going to duplicate the point separate node. I'm going to think of a new mask name like word gap for vertical gap. And I'm going to kind of steal these points here and feed them back into the point separate. And now whatever lands in this vertical gap mask should punch out holes only where there are no borders or no ground floor. The way this works is pretty similar to how we did the borders right now. I'm actually going to dissolve with Ctrl X this node, we no longer need it. And I will duplicate this attribute math. And instead of feeding this result into the borders, I will now choose my vert gap variable I just created. And instead of looking at the position Z, which wouldn't make sense, we either want to look at position X or Y now. It doesn't matter how you start. I'm going to start with X. And you can see that it gets funky immediately. First of all, this looks a little bit weird. If I lower like the frequency to something like 2, you can see that our modulo only applies to these couple of blocks, but not to those on the other side. And this wall seems to be completely broken. And I cannot even mathematically explain to you why this wall would be not just on or off, but doesn't matter. So let's fix this situation where only half of the wall is using the modulo. The reason is simple. Modulo only works with positive numbers. So around here should be 0, and we're counting up to the right, and everything left of 0 is going to be -1 to minus whatever. So we have to, I don't know, round them to be positive in a sense. I don't know if that's the right word here. It's done quite easily. I will just take this attribute math here, and I'll try, before I start to modulo my position x, I'm going to use an absolute operation on my position x. So I'm taking my position x, use an absolute operation and write it back into position x. And now all the negative values should be positive. And another thing that I'll have to do is, as soon as I increase the size of the building, make it one wider, everything disappears. The reason for that is that we now have essentially an uneven number which is divided weirdly, which means that we have like a float value in here. Long story short, I'll also need to round this position x value. So I'm going to duplicate it, set it to round or some other operation that rounds it. There we go. And now we should always get these gaps independent of what we input here. You might realize that it is not completely even, which is something that on the fly I don't even know how to fix that. The thing is, I didn't even think about it because I didn't mind having, I mean, it's always kind of symmetric to this axis, so I think it never looks like a bug or a mistake. I actually kind of enjoyed the variety, so I didn't even think about how I would fix that. You can maybe come up with a way. I'm going to keep it like that because I actually enjoy it, that sometimes we have a little bit of randomness in here. So now we have fixed up the walls that are facing in this direction. However, these two walls are still problematic. So I'm going to take these 3 nodes that we've just created and do the same thing for the Y position. Yeah, that's better. So this time we're going to look at position Y, position Y, position Y. Yeah, this time you see the entire boring process without a cut. And position Y. So now we have the same situation over here, and this should in theory already work. Let me make it a little bit deeper. No, something is wrong with the absolute. Oh yeah, I didn't properly correct. All right, so now the same thing works on this wall too. How do we combine those two values? Well, first of all, this vertical gap value is now overwritten. The vertical gap value that we created for these two walls is now overwritten by the ones for these two walls. So I have to give them a different name. So instead of vertical gap, I'm going to call that first one, I don't know, vertical gap B or vertical gap temp or something. And another problem is that right now you see sometimes the walls on our side that are capping off our nice moduloed gaps here are either completely empty or completely filled, or sometimes even worse with this kind of diagonal situation. So since we don't really have a rule what to expect here, we can't really combine, multiply, or somehow operate these two values together because those walls would always be weird and glitchy. So we kind of need to establish some kind of rule that these two walls at the end are either always completely full or completely empty, so we can kind of start thinking about how to combine them. And the way we can do this is if we scroll back to the very beginning of what we did. We actually declared the walls at some point. We have these bottom wall, right wall. I just see that top wall is written with a capital T as the only one. I don't know, I have to remember that. So we can combine these together. Let me start by duplicating this attribute math, and I will change this input B to an attribute, and I'm going to combine my vert gap with the top wall. At this point I don't know which one is the top wall. I don't remember. We have to try around until we get the right one. And instead of modulo, I'm going to choose maximum. And as you can see, as soon as I changed it to maximum, this wall disappeared. Quickly mute and unmute that to show that to you. All right. And now when I make this building deeper, you can see the other wall fluctuates and behaves randomly, but the top wall stays nice and steady. So let's duplicate this and do the same thing for the opposite wall, which should be the bottom wall. And now if I make it deeper, it should also fix this behavior, which is good. And now we just have to do the exact same thing again, just for the other two walls. So I'm going to get my attribute math node here, duplicate it to over there. And instead of the vertical gap now, I'm going to look at the vertical gap B. And I'm going to write the result into the vertical gap B. And instead of the top wall, I want the right wall. And the same operation again for the left wall. And now we just have to combine vertical gap and vertical gap B in a meaningful manner. So I will choose another attribute math node. This time I will select multiply, and I'm going to multiply vertical gap with vertical gap B and write that back into vertical gap, which is our point separate attribute. And now, as you can see, we have a very neat split here. And if I choose a different frequency, let's say 4 for this and 4 for that as well, well, we see that we have swapped the outputs around. So geometry 2 should be the straight walls, and into geometry 1 I'm now going to feed our gap. Let me quickly create a model for the gap. I'm just choosing a cube and I will scale it down to half, move it up half a meter, old drill by now. I'm going to give it a new collection, which I'm going to call gaps. And I will use this point instance node from over here, change it to gaps, if I can spell it correctly. And now I should be able to connect it up and fill in all those empty holes there with our empty cube. And in order to make it a little bit more appealing, I'm going to maybe find the right face here. That is the right one. And I'm going to move it inwards just a bit so we get like a little bit of variety here. And as I said, if you would have done this insertion of this point separate node a little bit earlier, before we add the borders, for example, let me quickly see if I can recreate it here. Let's say we would have put it in here instead. Then those gaps would override the borders. I don't really like that look though. Perhaps for your building it's the right step to take. For my building I'm going to have it as I had before. So I'm going to Control Z the way out of here. Yes, and that is how you create borders. Now the last thing to do obviously is connect it up to our input. I'm going to create a new input which I'm going to call gap frequency, or you can call it column frequency or whatever you think is appropriate. And I will, do I have any input? Yeah, here's an input node. So I'll take the gap frequency and plug it both into the modulo value for this one and where's the other one? It's a pretty long node tree by now. Here's the other modulo value. You can also plug them into different values if you want to control those gaps on both axes of your buildings individually. Whatever you want. So now if I choose a 2, we get every other column as a gap, and now I can increase this value and kind of get a little bit of randomness into here, which is very nice for such a building. And this should be now the second to last part, because I think the only thing left is the roof by now. Well, oh no, in the original building I also had this kind of second type of top floor, but I think with the knowledge you have right now, if you didn't just only follow, but hopefully also understood what I did here a little bit, you probably are able to do that already. Just a little hint how you could do it. Take a look on how we declared our ground floor. Where is it? Let me quickly take a look for the node. That's the problem. It's getting quite hefty right now. All right. If you remember, we just compared this ground floor to a float, and we said whenever the position z value, which is the height, is equal to 0, which is exactly this row here, we want to replace it with a ground floor. And if I would increase this value to 6, the ground floor would be on floor 6. However, if instead of, for example, equal to, we would have set something then less than, and if I increase this value now, you can see that every floor less than floor 5 would turn into the ground floor. And if I'd say greater than, for example, I could change all the upper floors, right? And well, now instead of writing this result into ground floor, I could create a new attribute called upper floors and point separated off at some point here, and that way could create upper floors that are different. We're not going to do that for this building now because, I mean, I kind of really showed you pretty precisely how you can do it. I realize that these longer part tutorials are a little bit more sloppy than the other content that I've put out recently. It's just not feasible to really edit out a completely 20-minute tutorial or something like this. That would take forever. I mean, it already takes forever. I think this tutorial series is already pretty neat, but I optimistically declare that this will maybe be my lowest quality tutorial series on this channel in the future. Let me know what you thought, and have a great evening.